In today's session, we want to have a look at question number 20 from the Edexcel GCSE Summer 18 Paper 1H, and it's to do with quadratic inequalities. So we'll begin by reading the question. It says n is an integer such that 3n plus 2 is less than or equal to 14 and 6n over n squared plus 5 is more than 1. Find all the possible values of n. In terms of terminology, relatively clear and straightforward, an integer being a whole number. How do we go about solving this question? We have to find which values of n, it says find all the possible values of n, which values of n satisfy both criteria. As in, they satisfy this criteria and they satisfy this criteria also. Now here it's not immediately clear what criteria n has to satisfy, nor is it here. We need n to be the subject of these inequalities. We need n by itself. And the way we rearrange an inequality is the same way that we would rearrange an equation. So we're going to do that for this first one over here, as it's simpler. So let's begin with that. We have 3n plus 2 is less than or equal to 14. Take away 2 from both sides and you get 3n is less than or equal to 12. Divide both sides by 3 and you have n is less than or equal to 4. So now I know that it says find all the possible values of n. They have to be less than or equal to 4. So I can't suggest, for example, 7 or 8 or 9, as they're not less than or equal to 4. But that's not the only criteria it has to meet. As we know, there's also this criteria here that they have to meet. So let's rearrange that also so that we have n in a form where we can easily work out what criteria it needs to meet. I'm going to begin by multiplying both sides of this inequality by n squared plus 5, by this denominator here. So if I multiply both sides by n squared plus 5, I would get 6n is more than n squared plus 5, because n squared plus 5 times 1 is n squared plus 5. Then I'm going to subtract 6n from both sides. If I subtract 6n's from both sides, I would get n squared minus 6n plus 5. And the reason I've subtracted 6n from both sides, and the reason I've written it in this order, is because this resembles when we're dealing with equations, an squared plus bn plus c equals 0. Now this is an inequality, and that's an equation. But we're going to solve this inequality the same way that we solve a quadratic equation that's on this form, an squared plus bn plus c equals 0. And the way we're going to do that is we're going to factorize in this case. So let's do that. Let's check if we can factorize. We're going to factorize into two brackets, n and n at the start, two numbers that need to make 5 when you multiply them, and minus 6 when you add them. So minus 5 and minus 1. If you multiply minus 5 by minus 1, you get positive 5. And if you add minus 5 and minus 1, you would get to minus 6. Again, this is mentioned in more detail when it comes to factorizing quadratic equations. I'm not going to go into the detail right here. What do you do with this information? We're now going to consider the critical values. The critical values are when this inequality, if you consider it as an equation and make this into an equal sign, so I'd have n minus 5 and minus 1 equals 0, right? So I'm rewriting this as an equation. What would be the two solutions? The two solutions would be n equals 5 and n equals 1. So they're my two solutions. They are referred to as my critical values, right? They're not the solutions for my inequality, but they are the limits for the range or ranges I want from my inequality. So those are what are referred to as my critical values. Okay, what do I do with this information? Next, when it comes to solving quadratic inequalities, I do a quick sketch of the curve. Now, how do I know how to sketch the curve? I use the critical values. I know it's going to cross at x equals 1. I know it's going to cross at x equals 5. And not that you need it in this case, but if you look at this form here, you can see that the y-intercept is also going to be 5. So let's draw that quickly here. I'm going to try and draw it as accurately as possible. Something like this. And so this value here would be 5 as well. This one here is 1 and that here is 5. I wanted when n minus 5, n minus 1 was less than 0. And when is it less than 0? It's less than 0 in this section here. So when n is between 1 and 5. And the reason we're not writing less than or equals to is because this original equation was strictly more than, and it's remained strictly more than or less than throughout. So it's going to be the same here for the solution. So that means then the values of n have to be between 1 and 5, and they can't be 1 or 5. Now it says here, find all the possible values of n. And it says at the start that n is an integer. So what are the integer values between 1 and 5, not including 1 and 5? Well, there are 2, 3, and 4. And you can see previously we had the criteria that n has to be less than or equal to 4. And so those three values I just gave you, 2, 3, and 4, also meet this criteria. If they didn't, I'd have to exclude the ones that don't meet that criteria. But since they do, then my solution is going to be that n can either be 2, or 3, or 4. As they are the three integers that meet the criteria of being less than or equal to 4, and also being between 1 and 5. So a quick review of the question then. We took the first inequality, we rearranged it to make n the subject so that we found that n has to be less than or equal to 4. We took the second inequality and it's a quadratic inequality, so we factorized it and we solved it as though it was an equation to find the critical values. We sketched the curve and we used the original direction of the inequality to assess whether we needed that which is above or below the x-axis. Here it's where it's less than 0, so it's below the x-axis. That corresponds to the range of values between 1 and 5. So we found also this limitation that n has to be between 1 and 5. If you gather between those two criteria, there are only 3 integers that meet those criteria, and they are 2, 3, and 4. And with that, the question is complete.